Hello students, hope you are doing well. Today we are going to discuss about the surface and interfacial tension. This is another topic from Physical Pharmaceutics 2. Now today's class we are going to discuss about surface, interface, surface tension and interfacial tension, types of interfaces and different applications of the surface and interfacial tension. Let us start with the surface. So generally surface of any substance, it is the portion where a part or the portion which can expose to the air, and that portion is known as surface. Say for example, if we are taking any substance, this is a substance, and if considering this portion of this particular substance is exposing to directly with air, this is known as surface of the substance. As we discussed just now, the portion of a substance that exposed to air, it should expose to the air, and that is known as surface. Surface can be found in solids, liquids and gases. So there are three different materials we'll be having here. So solids will be containing the surface, liquids and gases as well. To understand the surface in detail, here we can take a substance as liquid. So this liquid can be taken in a beaker, and this will be containing with some molecules like this. This will be a beaker, and in this beaker we can take some liquid as a substance. So this uppermost portion, this uppermost area of this liquid will be exposed to gas. This is known as surface of the particular liquid, and here we will be having another molecules. So but what about this another molecules which are under this surface? So this is not directly exposing with gas, so these are known as bulk molecules. Now we'll discuss about the interface. So the interface is the boundary that forms between two different phases, is known as interface. So to understand this interface, let us take oil and water as two different substances, and when we are trying to mix these two different substances in a beaker, here we will be finding a boundary like structure, and this boundary is known as interface. Now we'll discuss about surface and interfacial tension. Surface tension is the tension or force that acts on the surface of liquid in all possible directions. In other term, surface tension is the phenomenon that occurs when the surface of liquid is contact with another phase, especially with gas. Surface tension is a physical property of liquids. Mainly the surface tension is occurred due to the cohesive forces. So cohesive forces, the attraction forces in between two same molecules that can be comparable each other. This type of forces are known as cohesive forces. To understand the surface tension, let us take a sample as water. So this will be the beaker, and in this beaker we have a substance called water. So if you look into this molecule, this is a molecule, and this molecule is affected by the tension or force on its surface in all possible directions, in these directions. So here in all these possible directions this molecule is affected. So here the force will be 0. Equal and opposite forces will be applied on this molecule, so the force will be 0. So as per the definition we discussed, surface tension is the force which acts on the surface of any substance. So that means if we take this molecule here, so we can see the forces will be acting this side, and downward side like this. But this upper portion is directly exposed to air. Hence, this phenomenon is known as surface tension. The units of surface tensions are in CGS units, dynes per centimeter, and in SI unit system, newtons per meter. Interfacial tension. Interfacial tension will be denoted by gamma LS. Interfacial tension is defined as the force or tension per unit length existing at the interface between two immiscible faces. In another term, it is also known as the boundary that separates two immiscible liquids is also known as interfacial tension. Interfacial tension arises due to adhesive forces. The adhesive forces are the attractive forces between two dissimilar molecules. That means the forces will act in between two different molecules. This type of forces known as adhesive forces. The units of the interfacial tensions are in CGS system, dyne per centimeter, and in SI system, newtons per meter. Here you need to understand one thing: the units of surface tension and interfacial tension both are same. To understand the interfacial tension, let us take two different samples. Those are oil and water. So this oil and water, when we are trying to mix this oil with water or water with oil, this mixture cannot be mixed properly. Hence, this can be taken as an example of interfacial tension. So, when we are trying to mix this oil and water together, we can find this boundary like structure in the sample itself, and the forces. Because of the adhesive forces, this boundary will formed. Okay, so now because of this adhesive forces, the boundary will be formed, and this phenomenon is known as interfacial tension. There are different types of interfaces. First one, liquid and gas interface, and the example for liquid and gas interface is water surface or solutions. We can consider as an example of liquid and gas interfaces. Solid and gas interfaces, example for the solid and gas interfaces are aerosols and tablet surface. Liquid and liquid interfaces, example for this liquid and liquid interfaces, example is emulsion. Solid and liquid interface, example is suspension. To understand this types of interface, we can consider a liquid in a beaker and with some solid particles. So this liquid is directly exposing to gas. That is the reason this is liquid gas interface. Now let us consider this portion. This portion is only with connecting with liquid plus liquid. Both molecules will be in liquid form. That is the reason it is known as liquid and liquid interface. Now let us consider this portion. in this portion we have two different molecules, that is solid and liquid molecule. Solid and liquid molecule, that is the reason this portion is known as solid and liquid interface. Applications of surface and interfacial tension. This mechanism of surface and interfacial tension widely applicable in the pharma industry and cosmetic industries to prepare or to manufacture different dosage forms like suspensions, emulsions. Whereas coming to the cosmetic industries, there are also whereas coming to cosmetic industry, we can prepare the creams, lotions and other semi-solid products. In pharmaceutical industry, the major application of this surface and interfacial tension, this technique can be used in coating of tablets. The surface and interfacial tensions can be applicable in the stability of emulsions, also used in the formulation of drug delivery systems such as nanoparticles and liposomes. This is about today's topic. Thank you. Hope you are understood.
Like, share, and subscribe. Hit the bell icon for more updates.